Control units or modules use different languages or protocols to communicate, and these range from low speed communication protocols, medium speed, and high speed. Examples of these communication protocols include the J1850, which comes in two flavors, the VPW, which is a variable pulse width, and PWM, which is pulse width modulation. And we also have the K-line and L-line. We also have the LIN network, which is local interconnect network. We also have MOST, which is media oriented systems transport, FlexRay, and automotive Ethernet. Uloji Steven is my name, and I'm the head technician at Nana Auto Diagnostics. And today we shall be explaining the different terminologies that are used in automotive communication networks. Just like any other language, communication in automotives also has a unique set of terminologies that are used to describe communication between the modules themselves and communication between the modules and the scan tools. Now, communication is a broad topic of discussion, but I will restrict my explanation on terminologies associated with automotive communication networks. And we shall begin by defining what an automotive network is. An automotive network is a group of computers, you can call them ECUs, which translates to electronic control units, or modules or nodes that are connected together by either single or multiple cables known as the transmission media or data bus. So this communications network serves as the nervous system of the vehicle, as it connects various ECUs and the sensors which are spread around the vehicle. The next terminology that we shall look at is the transmission media, and this is defined as a physical or wireless communication channel that carries data signals between devices. Now, this transmission media may be wired, or some of you know it as being a guided media. In other words, it uses physical wires to relay information from one module to another. Now, examples of networks which use this type of communication include the J1850 communication protocol, K-line, LIN, which is local interconnect network. We have CAN bus, which is controller area network, and FlexRay. For the case of the wireless, or you can call it the unguided media, it does not require physical wires to relay information from one point to another, or from one module to another. Instead, its communication is done wirelessly. I'll give an example of a TPMS sensor communicating with its module. Now, TPMS is a tire pressure monitoring system, and it uses sensors which are located within tires to measure the pressure at any given time. So this information is relayed to the control module wirelessly. In other words, there is no physical connections between these sensors and the control module. The next terminology that we shall be looking at is the network topology. And this defines how ECUs are arranged in the network. So there are quite a number of network topologies, but I will restrict my discussion to only those that are relevant in automotive communication networks. Examples of these network topologies include point-to-point, bus network topology, ring network topology, star network topology, and tree network topology. I will not explain these network topologies in detail right now. Rather, I will go in depth when trying to explain how each topology applies to a given network that I will be discussing. The type of network topology to use on any given network will depend on quite a number of factors, and these are some of those factors that are considered when choosing any given network topology. So one, we have the cost, we have performance, reliability, scalability, and security. When I'm discussing communication networks, I'll put these factors to use as we are explaining the performance, which is basically measured by how much data any given network can transmit in a particular period of time. We shall also talk about its reliability, the scalability, how easy it is to add a module or an ECU to that given network, and the security that network offers to any given systems or ECUs that are operating on that network. So next we are going to talk about network impedance. So what is network impedance? Impedance refers to the total opposition of alternating current in any given circuit. And it carries two parts to it, which is the resistance part and the reactance. Now reactance is the opposition to the flow of AC in either an inductor or a capacitor. So as it pertains to automotive communication, I will define network impedance as a resistive component to the data bus circuit, and it's usually chosen to prevent signal degradation, minimize errors and latency in communication networks, and can be configured using terminal resistors. So we shall be able to look at this in great detail, more especially when we are talking about the CAN bus network, which is a controller area network. And we shall be able to look at those terminating resistors. They're usually 120 ohms. And we shall see how the networks are arranged and what role they really play in the network. Next, we are going to be looking at the gateway. And a gateway is an ECU which allows the exchange of data between networks using different languages or protocols. It acts as an interpreter. A gateway module can either be a standalone module or it can be incorporated within other modules, such as the instrument cluster. In a vehicle, there are many communication languages or protocols, such as the K-line, the J1850, the LIN, the CAN network, FlexRay, automotive Ethernet, and others. And all those communication networks use different languages. So in case one ECU, let me say, which is operating under FlexRay, such as the EPS, which is electronic power steering, module wishes to communicate with the engine control module, which operates on another network, such as CAN network. So their communication must go through a gateway module, because these two are literally speaking different languages. So in that case, the gateway acts as an interpreter. To understand this better, just imagine the ECM is speaking Runyoro. For those of you who don't know Runyoro, this is a local language that is spoken by the Banyoro, and this is a local tribe in Uganda, trying to communicate with the EPS, which is the electronic power steering module. And in this case, the EPS is speaking English. So we all know that we can't have any communication in that kind of setting, because these two modules are literally speaking different languages, and they can't come to a common ground at any one point. So where am I going with all this? I'm trying to bring to your attention that whenever you have two or more modules configured on the same network, we always communicate with each other, and that communication may not have to go through the gateway because they are speaking the same language. So it's like a Munyoro speaking to a fellow Munyoro. So in that case, a translator would be useless. On the other hand, whenever you have two or more modules that are configured on different networks, their communication must be routed through the gateway in order to interpret the messages that are cutting across those networks. So this will be evident in our diagnosis as we proceed. You realize that whenever you have faults in the network, with the help of the wiring diagram, we can be able to identify which control units are on the same network and which control units are on a different network. And that will help us to carry out our diagnosis efficiently. Let's move on to our next terminology, which is protocol. Now, protocol is defined as a set of rules that govern the style of communication to be used between ECUs, which are electronic control units. Now, for ECUs to communicate with each other, they must speak the same language. Otherwise, their communication must be routed through the gateway, as we have explained it earlier. In any language, there are guidelines which govern how communication is to be achieved. And these guidelines vary from language to language. Among the Baganda, women usually kneel down when greeting. But this practice does not cut across other tribes in Uganda. So every language follows rules and standards that must be met if communication is to be achieved. And these standards must be adhered to and are usually defined within the protocol. Next, we shall be looking at multiplexing. And multiplexing is defined as a method that is used to combine multiple messages into a single message. And that is what we refer to as maxing, which is then transmitted over a network and split back into multiple messages, which we refer to as demaxing. I'm going to explain this concept using a car carrier truck. Now just imagine we are transporting 10 cars from Kampala to Jinja. So we are presented with two options: either to drive the 10 cars separately or to load them on a car carrier truck. You can agree with me that loading the 10 cars on a single car carrier truck is a better option because it saves time, fuel, and traffic on the road. Let's see how this analogy relates to multiplexing. So we define multiplexing as a method used to combine several messages into a single message. So we are loading these 10 cars, which are being representative of the many messages that we are trying to transmit over the network. So in this case, we are combining the 10 cars and loading them on a single car carrier truck. So this explains the maxing part of it. And then this single truck is going to be driven by road. Now the road in this case is our communication channel. You can tell that using this system of combining several messages into one will always reduce traffic on the channel. So if you had 10 cars being driven on Kampala-Jinja highway, it would create a lot of traffic as compared to driving a single truck carrying these 10 cars. Once they have reached their destination, which is Jinja, they are going to be unloaded. And this is what we call demaxing. So we are obtaining the original or the messages that were combined before. So I hope with this analogy you've tried to understand what multiplexing is. So let's look at the advantages of multiplexing. And one of the advantages, we say it reduces traffic on a communication channel, and that is embodied within the efficient use of bandwidth. And two, there is reduction in wire count and hence harness weight. And this system is reliable and it allows fewer components and connections, which in turn reduces costs, and it also incorporates diagnosis. So when we are talking about communication networks, these networks employ usually two types of buses. We have a single wire bus communication network. We also have a differential bus network, which uses a twisted pair of wires. For a single wire bus network, it transfers signal over a single wire, where the voltage levels are measured with reference to ground to convey the transmitted data. It is used in non-safety critical systems, and any fault on this system, it will affect the entire communication of the modules that are connected on that bus. Examples of networks which are wired using the single bus network include the J1850 communication network. We have the K line and the L line. We also have the LIN, which is local interconnect network. And for the differential bus networks, these transfer data over a twisted pair of wires, where the voltage difference between the two wires conveys the transmitted data. The differential bus network finds its application in communication networks such as CAN, which is controller area network, and FlexRay. So we shall be looking at how the voltages are varied to convey the data. And the way CAN varies its voltages is different from the way FlexRay varies its voltages. Next, let's look at encoding and decoding. Now, encoding is the process of converting values into secure data for transmission and storage, whereas decoding is the process of reconverting the encoded data into the original values. Let me use the concept of a TV station broadcasting news to understand this concept, and later we shall see how it applies to automotive communication. Just imagine you have tuned in NTV and you are watching NTV Akawonges. Do you know how you are able to receive that information that is broadcasted from the cameras at the TV station to your TV in that sitting room? At the NTV broadcasting station, there are transmitters, and these transmitters contain encoders which will convert the footage or the videos which have been captured by the cameras into radio signals. Now these radio signals will be amplified and transmitted into the space. Now at your home, you always have that antenna. Now the antenna will receive the signals and send those signals to your decoder. Now some of your televisions have inbuilt decoders, and others you have to buy separate decoders. And the decoders will convert those radio messages into a video message which will be displayed on your TV. So how does this process of encoding and decoding apply in automotive communication? I will use a case of the communication between sensors and control modules. And in particular, I will use the engine coolant temperature sensor, sometimes known as the ECT sensor. Now this sensor monitors the temperature of the engine coolant, and we always report its findings to the engine control unit or module. The changes in temperature of the engine coolant is accompanied by the changes in voltage levels at the ECT sensor. A special chip will then encode these messages, pack them into a short message which will contain an ID. Now this ID will enable the engine control unit or module to know where exactly this message is coming from. The ECU will then read this message and be able to know how to respond. It can either turn on a light on the dashboard depending on how it was programmed. So this would explain the decoding part of it. Next, we shall define a bit, and this is the smallest unit of data that a computer can process and store. It is usually a 0 or a 1. Next, we shall define a nibble, which is a group of 4 bits, and from there we shall upgrade to a byte, which is a group of 8 bits. The next term that we shall explain is frequency, and frequency is defined as the number of cycles made per second. So we shall use this and other terms when we are doing the analysis of waveforms, bit can waveforms, bit lean waveforms, and this will be a very important tool to measure how fast the communication is happening on a given channel. The next terminology that we shall be explaining is bandwidth. Bandwidth is defined as the maximum amount of data that can be transmitted over a bus or a network in a given time period. And this is measured in bits per second. We realize different networks have different bandwidth. For instance, K-line network has a bandwidth of 10.4 kilobits per second. That of LIN is 20 kilobits per second. That of CAN can stretch to 1 megabits per second, and FlexRay can go up to 10 megabits per second. So we shall look at those still in detail as we are looking at those communication networks. The next terminology that I wouldn't like to go without mentioning is the baud rate. Now, baud rate is defined as the total number of signal transitions, that is from high to low, on the bus per second. Now, this is going to be a very important parameter, especially when we are doing waveform analysis of these networks. So we shall look at it in detail when that time comes. So as we are concluding, let's explain a few terminologies, and one of them would be half-duplex. Now, half-duplex is a mode of communication that occurs where modules are able to communicate on a given channel, one at a time. Once the transmission is done, then the other modules can respond. So this mode of communication is usually common in walkie-talkies, and its counterpart is full duplex. Now, full duplex is a mode of communication that occurs where different nodes can communicate over a channel at the same time. So there is back and forth communication at any given time. For example, the communication on a mobile phone. Both parties can be able to send and receive data at the same time. So that it would be considered as a full duplex mode of communication. And lastly, but not least, we shall look at synchronous and asynchronous. Let me begin with synchronous. Now, synchronous comes from the word sync. Now, if you are in sync, it means you are literally moving together or at the same time. So, synchronous communication is that communication that is achieved when devices have a shared clock. And for asynchronous, it is a type of communication where devices don't have a shared clock. With that, I want to thank you for being such a wonderful audience. And in our next video, we are going to start looking at these communication networks in details. And we shall begin with the SAE J1850 communication protocol, which comes in two flavors, the VPW and the PWM. So this communication protocol is usually in legendary cars. These cars stem from the US, and they include those from the GM group, which is General Motors, and Ford. So if you have one of those cars, please don't miss that video. And if you have not yet subscribed to this channel, now would be the right time to do it. Subscribe, hit that notification bell so that you'll be able to receive notifications whenever we upload a new video.